Okay, welcome back. Let's keep on going here with a few different rules this time. Let's put all of these rules together and let's see what we can do as far as simplifying expressions that look like these guys down here. They look a little bit difficult, but that's all right. If we know our rules and we can handle them one at a time, this actually becomes relatively easy. So let's see what we've got here. Well, of course, we've got our addition rule. A to the m times a to the n is equal to a to the m plus n power. We've already seen this rule. A to the m times a to the mth power raised to the nth power is a to the m times n power. Again, we've seen this. A times b to the nth power is the same thing as a to the n times b to the n. And a to the m over a to the n, we just talked about this, was a to the m minus n power, provided our base a does not equal 0. Similarly, for a to the negative n, 1 over a to the positive n is equivalent, as long as the base is not equal to 0. And a to the 0th power equals 1 for any base a other than 0. I'll point out this rule right here is really just a restatement of the rule above it, so we really don't even consider it a separate rule. There's 6 rules right here. There's one more rule that I did not state, and it kind of related to our third rule up there. If I had a division in which a was divided by b and I raised that to an exponent n, that would be the same thing as a to the nth power over b to the nth power, and we'll use that in a while. Again, this one will be provided that b is not equal to 0 this time because we don't want a denominator of 0. Okay, so how do we use these rules? Well, let's check it out right here. Let's look at this first awfully monstrous looking expression. Terrible stuff. You've got 3 times x to the negative first times y to the fourth divided by 6 to the negative 1 times x cubed times y to the negative 2. Whenever I see an expression that contains variables and constants multiplied together, probably the easiest way to handle it would be to divide up the expression so that you're multiplying 3 different fractions. We've got 3 divided by 6 to the negative first power being multiplied by x to the negative first power over x cubed times y to the fourth power divided by y to the negative second. And one of the first things I always do whenever I have negative exponents is to rewrite the expression so that I eliminate negative exponents. Right? Always do that first. And the reason why is that, well, dealing with negative exponents is always kind of hard. And so it's a lot easier to make sure that we handle those exponents first and get them out of the way, right? So we've got 3 divided by 6 to the negative 1. Well, by this rule right here, anytime we have 1 over something to a negative exponent, that negative exponent is going to change the position of the base. So it really becomes 3 times 6 to the first power here. We've got x to the negative first over x to the third. I don't like that negative 1 in the numerator, of course, by our rule right here that says take that to the denominator to change the sign of the exponent. So this is really like saying 1 divided by x to the first, and x to the third stays in the denominator. And now we can look at this last one over here. I've got y to the fourth in the numerator. That's a positive exponent, so I don't really need to change its position or anything like that. So I've got y to the fourth in the numerator. Pretty good. But I see this y to the negative second in the denominator. I don't like that as much. It's got a negative exponent attached to it, so I changed the position of the base by moving it to the numerator. In this case, this becomes y to the second. So now let's handle our multiplication. What do we got here? Well, 3 times 6, we know that to be 18. Then we can use our addition rule right here that says we've got x to the first times x to the third. Even though it's in the denominator of the fraction, it works the same way. We're going to get x to the fourth down here. And we've got y to the fourth times y to the second. Again, this is the addition rule. Y to the sixth in the numerator over 1. And then we should reduce our fraction. So let's rewrite this. This is 18 over 1. So remember, it's numerator to numerator, denominator to denominator. We're going to get 18y to the sixth divided by x to the fourth as our resulting expression. All right. It turns out that's not so bad once you separate it out. Just take your time and write out each fraction. How about this guy right here? There's a couple different things going on. Well, let's take a look. I've got 3a. Now, there's really not much I can do with 3 times a. I'm going to just take it out of the parentheses here. We're going to have to find a way to take this guy out of the parentheses. Now, the way that we do it is that we're going to take advantage of this rule that tells us if we have two quantities being multiplied in a parenthesis, and both of those are raised to the nth power, we can take that power and raise it for each part of our product right there. So each of our factors, we're going to have 4 raised to the negative 2 times a to the negative 3 raised to the negative 2nd power. All right, so what does that do for us? Well, now we're going to have to rewrite it. Again, let's get rid of any negative exponents if we can. I would do that right here by, of course, taking 4 to the negative 2 and moving that to the denominator. So I've got 3 times 1 over 4 squared right here. Now, I would move my exponents around right here, except I notice that this actually looks like my multiplication rule right here, right? You see this one where we've got a to the m to the n, and if I have my two exponents up here, I can multiply them together. Now I'll note a to the negative 3 raised to the negative 2 is a lot like saying a to the negative 3 times negative 2, and that's pretty easy. That's positive 6 right there, so I won't even have to move that one. Now we can simplify. So we're going to have 3a, and we could think of that as being over 1. 1 over 4 squared, well, 4 squared, we know that to be 16, times a to the 6th divided by 1. If we put this all together, 3a times 1 times a to the 6th becomes 3a to the 7th. And of course, the denominator is multiplying straight across just gives us 16. So this is our resulting expression right here. More coming up in the next video.